evaluate the limit of sine x over x as x approaches infinity. This is a classic limit that demonstrates some key concepts in calculus. Let's start by writing out our limit. We want to find the limit as x approaches infinity of sine x divided by x. To understand this limit, let's first consider the behavior of sine x. The sine function oscillates between -1 and +1 for all values of x. This means that sine x is always bounded between -1 and 1. We can express this mathematically as -1 is less than or equal to sine x, which is less than or equal to 1. Now, let's think about what happens as x approaches infinity. As x grows larger and larger, the denominator of our fraction grows without bound. Meanwhile, the numerator, sine x, remains bounded between -1 and 1. This scenario allows us to apply the squeeze theorem. We can squeeze our fraction between -1 over x and 1 over x. Now, let's consider what happens to these bounding functions as x approaches infinity. The limit as x approaches infinity of -1 over x is 0. Similarly, the limit as x approaches infinity of 1 over x is also 0. By the squeeze theorem, since our function sine x over x is always between these two functions that both approach 0, the limit of sine x over x as x approaches infinity must also be 0. Let's visualize this limit. Here's a graph of y equals sine x over x. As x gets larger and larger, you can see that the function gets closer and closer to 0. In conclusion, we've shown that the limit of sine x over x as x approaches infinity is 0. We did this by using the squeeze theorem and considering the behavior of sine x and x as x grows large. This limit is an important one in calculus and has many applications in physics and engineering.